All right, the purpose of this video is to review how Bohr models are created. So before we really review how Bohr models are created, I want to just briefly recap what valence electrons are. Valence electrons are the electrons that are held loosely by the atom. These are found on the outermost energy level or outermost ring or orbit that you're drawing. These electrons are important because they determine specific properties of that element, including ways in which that atom can bond with other atoms. So we're going to start getting into chemical bonding in the near future, and you're going to be focusing on the valence electrons to determine how it will bond with other atoms. So we'll kind of come back to this at the end of the video. So when looking at Bohr models are important because they easily show how many valence electrons there are. As we said, those are important, but they also show how many total electrons an atom has as well. So it has a lot more information than some of the other models of atoms that you'll cover, and it really goes into visualizing how many valence electrons the atom has. So I'm going to scroll down and show you how to draw a Bohr model. So the first thing you would do is find your element on the periodic table. We are going to use sodium as our example today. And I have this little box here so that we can just kind of reference this. So we would find it on your periodic table. We've done that. You would abbreviate the number of protons and the number of neutrons. This will be the center of your model. So when looking at sodium, sodium has an atomic number of 11, meaning that it has 11 protons. And then we can use the mass to figure out the neutrons. So if we round our mass to, in this case, 23, subtract our number of protons, we would get our number of neutrons, which is 12 in this case. So sodium has 11 protons and 12 neutrons, and that's what we're going to start putting on our model. So I'm going to write 11P, and I'm going to mark protons as positive, and then I'm going to put 12N. And this is going to be the very center of our model. So I'm just going to kind of box this out to represent our nucleus of the atom. Okay, remember, protons and neutrons are what's in your nucleus, so that's what you just drew. Now going back up to our directions here, we've done number 2. So looking at number 3, we're going to determine the number of electrons. This is how many dots we're going to have to draw on our model. So because we're going to assume this is a neutral atom, our number of protons should match our number of electrons. So because our atomic number is 11, this also means that we will have 11 electrons to draw as well. When for drawing electrons, we need to look at how many energy levels we need and kind of some rules for that. So we know we need 11 dots. We've done step 3. Now we're going to look at step 4. It says use the following rule to help guide you on how many energy levels will be needed to include. This will be modeled as rings. So our energy levels are modeled as rings, and we're going to draw them using some of these electron rules. So electron rule number 1 says once an energy level is full, we must add another ring to our model. So that's something that we have to keep in mind. And rule number 2 kind of tells us how many electrons an energy level can have before it's full. So the first energy level can hold up to 2 electrons, and then it's full. Whereas the second and third energy levels, or the outermost rings, can hold up to 8 electrons each before it's full. So those are some rules that we're going to have to keep in mind when we're drawing our 11 electrons for sodium. So I'm going to start with my first energy level, or my first ring. And looking at rule number 2 here, our first ring can hold 2 electrons. So I'm going to draw 2 electrons on this first ring. And then that ring is considered fuller. That energy level is full. So I can no longer put any more electrons on this ring, but I do need to still get to 11 electrons. So what I have to do is I have to add another ring, and I can add up to 8 electrons on this second ring because it's on the second energy level. Okay. Note that this is our first energy level, and then this is our second energy level. So I'm on my second energy level. I can hold up to 8 here, so I'm going to add 1 here, 2, and when you're adding electrons, you'll want to go around and add them one at a time, kind of like it's a compass. So 1, 2, 3, 4. I can hold up to 8, so I'm going to add 5. Once you get above 4, you're going to want to pair them up. So if you can see, I've kind of paired these two together and drawn them really close together. So I have 1, 2, 3, 4, 5, 6, 7, 8, and I maxed out. I've drawn the total amount of total amount of electrons I can on this energy level. Now this energy level is considered full. I can no longer add any more electrons. However, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total electrons, and I still need 11. So what I have to do is I have to draw one more energy level or one more ring around my atom and add my last electron there. So I'm going to label just for you guys, this is my third energy level. And keep in mind, you might have atoms that are bigger or elements that are bigger and require more atoms on this third energy level. Once again, the third energy level can hold up to 8 electrons. For the purpose of this class, you will not be drawing more than 3 energy levels. They don't always follow these rules, and there's other exceptions, and they just get really big and complex. So we're going to stick to only elements that have 3 energy levels or less for this class. One thing I wanted to point out before we move on is the valence electrons. Remember, valence electrons are the electrons on the outermost ring. So when I'm looking at valence electrons, I am looking at the ring furthest away from the nucleus. So in this case, we have 3 energy levels. So our valence electrons are only the ones on this outermost energy level. So we only have 1 valence electron for our sodium atom. And that is how we draw a model, a Bohr model of sodium. I'm going to do just a few more quick examples for you, just so that you can see some of the different atoms we have. Hydrogen has, I'm going to do hydrogen here next. I'll keep it in orange for you guys. So hydrogen is the one we're going to do now. Hydrogen has an atomic number of 1, meaning that we have 1 proton. And its mass is 1.00, meaning that it really doesn't have any neutrons. So I'm going to put 0N as my nucleus. I'll box off my nucleus. And then because its atomic number is 1, it means it has 1 electron. So I'm going to draw 1 ring with 1 electron on it. And that would be all I would do for my Bohr model of hydrogen. Now, hydrogen has 1 valence electron. I just wanted to point that out to you so that when we're talking about valence electrons, you kind of know which one I'm talking about. So it only has 1 total electron, and that is its only valence electron as well. Last example I'm going to do with you, let's do nitrogen together. I'll use purple for this one. Mix up our colors here for fun. So our Bohr model for nitrogen, First of all, we have to look at its atomic number. Nitrogen has an atomic number of 7 when I look at my periodic table, which means I have 7 protons, and its atomic mass is 14. So if its mass is 14, 14 minus 7 gives us our number of neutrons. So that means we have 7 neutrons as well as 7 protons for this atom. So now all that's left to do is to draw our electrons. Remember, our electrons should match our number of protons, and because we have 7 protons, we need to draw 7 electrons to make this a neutral atom. So I'm going to start by drawing my first energy level, and that energy level can hold up to 2 electrons. So I have 2 electrons there, but that's all I can put on that energy level. It's now considered full. So I need to add 1 more energy level. And this next energy level can hold up to 8. We only need to get to 7, and we already have 2. So I'm going to add 5 electrons to this energy level. Remember, you're kind of moving around in a circle like a compass. So we have 1, 2, 3, 4, 5, 6. I need to draw 1 more to make 7 total electrons. So this would be all I would draw for my Bohr model of nitrogen. I just want to take a moment and once again point out the valence electrons to you. Nitrogen has 5 valence electrons. Because we have 1, 2, 3, 4, 5 on our outermost energy level. So once again, for your Bohr model, you would only have to draw what's drawn in purple here. But I wanted to point out to you which ones are the valence electrons, and they're the electrons on the outermost energy level. And in this case, nitrogen has 5. Every element has its own number depending on where it is on the periodic table. So just kind of recapping, hydrogen has 1, which is different than nitrogen, meaning that these 2 elements are going to bond differently, and they're going to bond to different atoms as we get into that later. So there you have it. That's how you would draw a couple different examples of Bohr models or Bohr diagrams.